All right, so one thing to consider is that word problems are extremely popular when it comes to setting up proportions and ratios. Okay, so let's take a look at example two. It says your new iPod has 2 GB of storage and can hold about 500 songs. A similar but larger iPod has 80 GB of storage, and I want to know how many songs can that larger iPod hold. Okay, so this question is a little bit outdated, but you guys might be familiar with this relationship. The way it used to work back in the day is that there was no such thing as like Spotify or Apple Music. You had to download all of the music to your specific device. And it was basically this relationship. The more gigabytes you had on your iPod, the more songs you could actually hold. Okay. So as gigabytes went up, the number of songs you could hold also went up. So what we're trying to do is here, we're trying to set up a proportion to see, okay, exactly how many songs can I have on my iPod if I got 80 gigs of storage on my iPod? Okay, so before we do any sort of math, we basically got to make a decision. The two things that we're comparing in this question are gigs and songs. That's the relationship we're trying to dissect. So we have to decide with our ratio. It doesn't really matter what you pick, but you just got to decide, okay, what's going on top and what's going on bottom. What I'll do just to make it easier is, okay, on top of my ratios, I'm always going to have gigs. And then the bottom of my ratio, I'm always going to have songs. Like I said, it doesn't really matter. You could easily do songs over gigs, but just make a decision. And once you make that decision, you just have to stay consistent with it. Okay, so let's set up this proportion. So what they're telling me is if I got 2 GB of storage, 2 gigs of storage, I know that holds 500 songs. 500 songs. I already got that relationship. But what they're asking me is, okay, if I have 80 gigs of storage, how many songs does that hold? I'm trying to figure that relationship out. I don't know the exact number, so I'll just call it X right now. And if we solve this proportion, we'll be able to determine what X should equal. Okay, once you have the setup, you're going to follow that exact same principle of cross-multiplying and solving. Okay, so what are we going to do? We're going to multiply our diagonals. My first diagonal is I see 2 gigs and X number of songs. When I multiply these two things, I'll have 2 times X. And I'm going to set it equal to my other diagonal, which is 500 times 80. 500 times 80. And all we're trying to do here is if we solve for X, we'll determine the number of songs it can hold. Okay, so when I simplify this a little bit, I'll tell you that you'll get 2X is equal to 500 times 80, I believe is equal to 40,000. You can double check me if you want. And all I have to do to solve for the number of songs is divide both sides by 2. And I should get X equals 20,000. Once you finish the question, double check and ask yourself, okay, what was I trying to solve for here? I was trying to solve for the number of songs that the larger iPod could hold. It can hold 20,000 songs. Always give that thing a label and circle it. Okay, not super bad. Here's a little bit more difficult one. It says you need to make a scale model of a parade float. And it says the float is 5.5 feet high and 10 feet long. Your model will be 14 inches long, and I'm asking how tall should it be? Okay, so there's an actual like bigger float, but we want to make like a smaller replica of it to model it. Okay, the actual float is going to be 5.5 feet tall and 10 feet long, and then the model is 14 inches long, and I'm asking how tall the model should be. Okay, so there's two things going on here. There's two things we're comparing. We're comparing the height, and we're also comparing the length. Okay, so first of all, make your decision. What do you want to be on top? What do you want to be on bottom? Let's say height is on top, and then length is on bottom. Okay, couple weird things with this that we have to be careful about. When I talk about the float, I'm measuring it in feet, but when I talk about the model, I'm talking about it in inches. Okay, so before we do any sort of work, we got to get on the same page between these two units of measure. We have feet and we have inches. I think the easier option here is we want to scale, instead of writing this as feet, we want to multiply all these numbers by 12 and then rewrite it as inches. So let's convert 5.5 feet to inches. All we have to do is take 5.5 and multiply it by 12. And when you do that, you should get something like 66. I know that the actual float is going to be 66 inches high. And then do the exact same thing with the length. 10 feet times 12 should be 120 inches. Okay. The actual float is going to be 66 inches high and then 120 feet long. Okay. Now, let's set up our proportion. My first ratio is going to be the actual float. It's 66 inches high and 120 inches long. Okay, and because the replica is going to be proportional, I know that it's going to be 14 inches long. So remember, length is going to be on bottom here. 14 inches, but I don't know how tall my replica is going to be. I'm going to call this X. Okay, this is my actual float. This is my replica. I'm trying to determine how tall my replica should be. Okay, once you have the setup, go ahead and cross multiply and see what this thing looks like. First thing you'll see here is 66 times 14. And that's going to be equal to my other diagonal, 120 times X. 120 times X. Clean this up a little bit. So I believe 66 times 14 should give you something like 924. 924 is equal to 120x, and if you divide both sides by 120, you should be left with something like 7.7 is equal to x. What did we just solve for? We know that my replica, my model, is going to be 7.7 inches tall, or have a